Here we're asked to solve this radical equation. Let's begin by isolating this first term involving the square root. To do that, we add the square root of 2x plus 22 to both sides. Now at this point we can square both sides. Remember, doing this introduces the possibility for extraneous solutions, so we need to be sure to check our answers at the end. On the left side here we'll be left with 4x plus 21, and on the right side we know we have to distribute this. And that'll leave us with the first term squared, 1 squared is 1, plus 2 times the product of 1 times this square root will leave us with 2 times the square root of 2x plus 22, and then plus this last term squared. So we have 2x, the square root of 2x plus 22 squared. Now simplifying further, we have 4x plus 21 equals 1 plus 2 times the square root of 2x plus 22 plus 2x plus 22. Now 1 and 22 are like terms, so we'll add those next, leaving us with 4x plus 21 equals 2 times the square root of 2x plus 22 plus 2x plus 23. Now at this point we'll isolate this term involving the square root by simply subtracting 2x to both sides and then subtracting 23 to both sides. And that'll leave us with 2x minus 2 equals 2 times the square root of 2x plus 22. Now at this point I notice all the terms are divisible by 2. So we can simplify things if we divide both sides by 2 before continuing. Doing that leaves us with x minus 1 equals the square root of 2x plus 22. Now at this point we can then square both sides again. Squaring x minus 1, we're left with x squared minus 2x plus 1, and that'll be equal to 2x plus 22. And so at this point we're left with a quadratic, which can be solved if we obtain standard form here equal to 0. So we'll subtract 2x on both sides, and that'll leave us with x squared minus 4x, and then subtracting 22 we'll have minus 21 here on the left side equals 0. Now at this point we can factor. So factoring this quadratic, x and x, 3 times 7 is 21, and if we make the 7 negative and the 3 positive, we'll have a negative 7x, and a 3x adds up to negative 4x, and also positive 3 times negative 7 is negative 21. So it factors, and then we can then set each factor equal to 0. So either x plus 3 equals 0 or x minus 7 equals 0. So my two possible solutions are negative 3 or 7. Okay, now let's remember that we have to check these. And so recall the original equation, because here we're going to substitute x equals negative 3 and see if we get out negative 1, or positive 1, I suppose. Substituting in negative 3, we have 4 times negative 3, which is negative 12. Negative 12 plus 21 will leave us with 9. So we have the square root of 9 minus 2 times negative 3 is negative 6. Negative 6 plus 22 is 16. So the square root of 9 minus the square root of 16, the question is, does that equal 1? Well, we can see here 3 minus 4 certainly does not equal 1. And that doesn't give us a true statement, so negative 3 is an extraneous solution. We'll disregard that answer. Next, we'll check x equals 7. Substituting 7 into the original equation, we have 4 times 7, which is 28, plus 21 leaves us with the square root of 49, minus 2 times 7 is 14, plus 22 is 36. So we have the square root of 36, and we need to see if that equals 1. And here we can see 7 minus 6 certainly does equal 1, and we get a true statement. So x equals 7 is our only solution to this equation.